Good afternoon, everyone. So today we are here for the first practical session here of Applied Thermodynamics module. So I hope you all went through the announcement I posted last night in LMS. And also I informed you in my last lectures regarding the practical session today. So I didn't see so much of your batchmates so far join. I can see only 10 people join as long as now. So first of all, can you hear my voice? Any of the student can answer?
Yes, sir.
Yes, sir.
Okay, sure. That's good. So regarding the practical, as I informed you earlier in the lectures, the 100% attendance is a compulsory. So please attend on time. Please be punctual because we don't have enough time. And the practical sessions will be conducted by the demonstrator for this module, Engineer Tisandan. So he will be conduct the practical sessions, all the 7 practical modules, 7 practical sessions consecutively from this week onwards for 7 weeks, 7 Mondays. We will conduct every Monday from 1 p.m. to 4 p.m. So as you know, this time we don't have enough facility to do the practical sessions. We can't have the hands-on experience. So we will try to do as much as possible what we can. So we will have all the recorded sessions, recorded practicals. The demonstrator, he will explain you. He will show the video, recorded video, and he will explain you the theory behind. Initially, he will explain the theory behind, and he will conduct the practical. Then, if you have any questions, like in lectures, you can interrupt him anytime. You can disturb him. You can stop him. Then you can ask questions in between, or else. At the end of the session, at the end of the practical session, you will have the discussion time, maybe like 20 to 30 minutes for all the practicals. So during that time, also you can discuss. You can discuss with your friends, and you can ask questions. And also, please remember your laboratory submissions. You will be given lab report submissions. You will be given 1 week time for the submission. So please be on time. Otherwise, you will not getting the full marks. Like if you delay your submissions, then you will get the penalty. Like 50% only you can get. That 50% also only allowed for within 2 weeks the submission. So if you delay the submission and you can submit the lab report within the 2 weeks, then you can get the marks out of 50. Instead of out of 100, you can get out of 50. So if you delay more, if your submission is more than 2 weeks, then you cannot able to submit. The system will only allow the submission until 2 weeks. But please remember, the submission you have to make within 1 week to get the full marks. If you delay more than 1 week, then you will get only half marks. Like your marks will be graded out of 50 instead of out of 100. So so now I can see 18 participants. So if you know any of your friends, they didn't join yet for this practical, please give them a call and ask them to join as soon as possible. So that we can start the practical as fast as possible. Then we can end the session on time also. We don't need to delay the practicals. So please give the support, your support to the demonstrator Tisantan. Then please follow the same standard of the lectures. Please write down your e-number, follow the standard format, and follow by your name on the chat bar, so that it is easy for the conductor, the practical conductor, to make the attendance for yourself. Otherwise, he need to call you one by one. It is difficult for him also. So please follow the same format as lectures. Write down your registration numbers followed by your names, so that he can able to mark up your attendance. All right, I can see one person is already wrote Pereira. Yeah, that's correct. So everybody please follow for your attendance. Then please ask your friends also join as early as possible. We are already 10 minutes past from 1 p.m. So we have to start the practical as early as possible. So ask them to join. At least if we have 25 participants, then we can start. Then the rest we will allow them in between the practicals. Okay, so besides the practical, last night I posted your tutorial one in the LMS also. So please download the tutorial one, and your submission deadline is coming Monday midnight. So meaning is next Monday, 21st of June, by 23 hours and 59 minutes. You must be submit within that deadline. You must be submit your tutorial one, the answer sheet. So for that tutorial one submission, I also give the instruction what is your requirement and how the submission format and all. Please go through the announcement. I don't want to talk about it here. Maybe I will remind you in tomorrow's lectures. I will give you another announcement. I will remind you in tomorrow's lecture. So today, please focus on the practical. Try to understand the practical sessions because I know it's hard for you to see the recordings and to understand without the hands-on. So please ask as much as possible the questions to the conductor. If you don't understand anything, you can stop him in between. You can disturb him. Then ask the questions. And also please submit your laboratory reports on time. So all right. So now, so far 19 participants. I think your batch got 31 people. Okay, now it's one more 20. Please ask your friends to join. Please give them a message, or please give them a quick call, direct call. Ask them to join as early as possible so that we don't need to waste our time. Why I'm repeating this announcements here, because this is the first session, and maybe somebody faced difficult to join, somebody missed out the announcement and all. From next week onwards, we will sharply start the practicals by 1 p.m. So please don't delay. Please don't delay and join on time. And also, again, remember, the 100% attendance is must. 100% attendance is a requirement for your eligibility criteria for this module. So don't take it easy. Please be responsible. Okay, someone is joining and going out. Maybe the connection issues. So that is okay. All right. So we can't delay anymore. So we will start the practical. Then please remind your friends to join. If anybody miss out this practical, please remember we will not reschedule the practical without any valid reason. Like if you are hospitalized, you cannot able to join today. If you are really sick, then you have to submit your medical certificate for the reschedule of this practical. Otherwise, we won't be reschedule any practicals. And if you miss out any one of the practicals, then you will be in trouble. So please take note. Practical sessions are as important as the lecture sessions. So please give the same importance for the practicals, and please give your support to the demonstrator also. So I will hand over the practical session to Tisandan here. So he will be taking over from here onwards. So anything you can ask him, or you have any doubts regarding the lectures or regarding the theories, then you can write on the email also. That is okay. So Tisandan, okay, you can carry forward from here onwards.
Thank you, sir. Thank you for your introduction. And I think, do you all hear me?
Yes, sir.
Yeah. Okay.
Yes, sir.
So did you refer that lab sheets from the LMS? Someone you can answer, right? While doing practical. I think you all got that lab sheets, right, from your LMS, right? Did you read before coming to practical?
Sorry, sir.
Did you read that lab sheets?
No, only sir, we download.
Yeah, you can. I uploaded before, I think, at least 5-6 days before this practical. So same as the next practical also, I will upload before at least 5 or 6 days. So it's better to download and refer, right? Read it, that lab sheets. It's better, right? So this is today's practical is about first law of thermodynamics. I think you all heard about that, right? I am now sharing one slide, right? PowerPoint slide. So if you didn't, if you couldn't find out this slide, you can ask, right? While doing this practical. So I think we can start. I don't know what to do to others, right? There are wait, someone is waiting. 3 people. Yeah. Okay. Now it is 23 is here, right? When we wind up this session, I will re-ask you that type your index number, then I will take it as attendance, right? So I should submit the attendance, and also that is the decisions depend on the module coordinator. I don't know about that what they are going to do for this if you that who is not participated. So it is up to Ranjan sir. So now we will start, right? The first law of thermodynamics, right? I think you have covered this theory in your lecture session, and so this is a simple thing, right? To demonstrate this from this practical, the objective is to by doing demonstration, right? Demonstration. This very simple demonstration we can do while in our home also we can do, right? I did one demonstration in our home and take video. I have videos and I will show you later. So from doing some demonstration, we can really understood about this what is first law, right? So that is the objective of this practical. Someone is coming. Right. It is interrupting while doing practical. Someone's coming. I think time is now it is yeah 1:15, more than 1:15. So it's from next practical onwards. Please be on time. Right? We don't need to be delayed, right? So this is the first law of thermodynamics. From this practical, after this doing this practical, you able to understood that doing demonstration, you able to understood where we use this first law and how can we apply this first law, right? What are the practical application of this first law of thermodynamics, right? Those things you should be able to understand, right? So this is the first thing. What is first law of thermodynamics, right? This is already covered in lectures, but I'll give some brief introduction, right? So it is very small small session, so that after this, I should make sure that you able to not only understand this first law of thermodynamics, you able to applicable, right, for any practical application, right? that should be the outcome of this practical, right? So someone is message. So internal energy of a system, right? Most of the system where we are playing this thermodynamics always AR, right? So later we will understand why we will use AR as a system, right? So internal energy of a system equals the net heat transfer to the system minus the net work done by the system, right? So equation is simply delta U is equal to Q minus W, right? But I will give you that exactly what is mean this equation, and there's two way we can write this equation, right? Delta Q is equal to Q plus W, delta Q is equal to Q minus W, like that. Here someone can write plus, right? That means only this the representative of W meaning will be, right, opposite, right? If it is work done by the system, here you should write minus, right? So if we are going to put plus to work done on the system, then we should put plus here, right? But most of the time we will use this one. So delta Q means the internal energy, right? Changes of the internal energy. That means if you are using that air as a system, then air have some chemical energy, right? If we take an example of combustion engine, there will be air fuel mixer no? That have the chemical energy, right? Then when there's flame occurs, when they burn, that chemical energy change the form into heat energy, right? That how we will introduce give the heat or energy to that system, right? I'm talking about that internal combustion engine, right? That is one example, right? Mostly usable example of this example for first law of thermodynamics. And change in internal energy, right? Delta Q, right? If the energy is increased, right? That means delta Q will be plus. If the energy of that air will be decreased, internal energy of air will be decreased, right? Then delta Q will be minus, right? When air is burning inside the combustion chamber, what will happen? By burning, that internal energy, that means that chemical energies change to heat energy. That means delta Q is decreasing. We can take like that. But if we are just introducing the heat, right? Not if we just say we are going to look that balloon and bottle, right? That system, right? I think we heard about that. It doesn't matter. It is better to discuss after we are seeing that, watching that video. So later I will explain, right? Just if the system internal energy is increased, then it will be plus. Internal, there's no change in internal energy, then 0. Delta Q is 0. Likewise, Q is what we give, right, to the system, right? If we give some amount of heat, that means some amount of energy, right? Heat is one form of energy, right? Simply take it as energy, right? We can produce energy, right? We can't produce, just we can change the energy one form into another form, right? When we give energy as heat to one system, then that will be plus Q. Here that will be Q, right? Heat added to the system, right? If heat come out from that system, some system, right? You can see when that combustion engine is working, there will be heat in the surrounding, right? In the vehicles and everywhere you can see that. That means heat come out from that system, right? That will be that. If we measure that one, that will be minus, right? So W means work done by the system, right? If system doing some work, that means there will be an increment of volume, right? There will be increment in volume, right? Then work will be the W will be plus, right? If you do it, do work on the system, right? Then there will be the volume should be reduced, right? That in that moment we'll take W as minus. Okay. So this is a simple description of this equation, right? So after this, I have we have to look two system and two experiment, right? Session for this demonstration for this first law of thermodynamics. So first, I will explain later. You can see, right? This is what we are going to see first, right? First video. I think someone is waiting. Two people are waiting. You can ask anytime, right? If you don't understood or if you hear some voice is not clear or something, you can ask, right? I don't know what is what is your opinion, right? Just ask. It doesn't matter, right? So the thing is that outcome should be the understanding of this first law of thermodynamics, right? You should be able to not only understand, you should be able to identify where we are applying this law and where we can apply, where we can write, right? Observe and what is happening, right? You should be able to understand those things, right? So this is the first experiment we are going to do. This very small experiment you also can do in your home, right? If you need hot water and bottle and one balloon, small one, that's enough, right? Then if you take this one, you can see, right? You have to fix the balloon in the bottle, right? So after that, this system is here. Balloon, the air inside the balloon and the bottle. That is a system, right? So now what we are going to do is we are going to apply. We are going to say we are going to give that now it is in this the first picture you can see this is in the surrounding area, right? Then air and the surround air should be in the same temperature. Then there will be no heat changes or heat transfer, right? So when we put this system under this hot water, what will happen in the figure 2 and figure 3, right? What will happen is heat will transfer from that surrounding that hot water to the system. That means the air which is inside the balloon in the bottle. That is our system. Then heat will be transferred to that. Then when the air catches the heat, then that will react, right? That will react. Then how it will react is that air, that system will do some work on the surrounding. That's why this balloon is expand, right? That's how this balloon is expand, right? So simply the Q is plus. Why? It is transferred to the system, inside the system, right? So that is why Q is plus, right? So therefore, simply when we consider the equation and delta U is equal to, we can say delta U is, we don't have, if you put suddenly, what will happen? We don't have, we are not giving time to increase the temperature of the air, right? Right. That will happen. What will happen is, if you take delta Q's, okay, same as 0, then what will happen? Q is equal to W. That means how much we give the heat we transferred, how much energy we gave to the system will equals to that work done by the system. Done by the system. System will do the work on the surrounding, right? That's why that it will increase the volume, right? Therefore, that balloon is expand, right? So I don't know, is everyone understood? Someone please tell me what do you understood this?
Yes, sir.
Yeah. Okay. What is your name?
Madhushan.
Madhushan. Okay. Yeah. Then Madhushan, do you hear me?
Yes, sir.
Yeah. Tell me, what will happen if we put this system to an 1 degree water? What will happen? The cold water. Now we are putting that system to that hot water now.
Yeah.
Yeah, this is hot water. We are putting hot water. That's why heat transfer to the inside the what air, right? To air, right? In the heat transfer to the system. What will happen if we put in cold water, like 1 or 5 degrees Celsius water or something? What do you think will happen?
Not heat transfer between the inside and outside.
Yeah, heat transfer Q is minus because inside heat is inside temperature of the air is higher than the outside water. Now water is minus 5 degrees Celsius, 5 degrees Celsius. No, that means the temperature difference is changed other way. Therefore, heat will transfer from the air to surrounding. Right? That in that time we will take Q as minus because Q mean heat added to the system. But if it is cold water, the temperature is lower than, very lower than from that that air, very lower than the system. Then the heat will be transferred from system to surrounding. That time, what will happen mean that it will react other way. That means that right, it will the surrounding will work will done on the system. That means this balloon or bottle will be string, right? That means string means it will that volume altogether the volume will be decreased. Somehow it will be decreased, right? That for that to do that one we will have other experimental setup. So I will by doing showing video you will understand. I am going to give some introduction so that clearly you will understand what is happening inside this looking the video. So we will move that video and see. Later, please ask if you don't understand. Right. This what I have done yesterday. Right in our home, I just check whether this how it is work. Right. So I just put get one bottle and balloon. And I'm explaining that here now system is what air, which is inside this balloon and the bottle, right? We have this. I make this hot water, right? So what I'm going to do is next I will put this system to that hot water. Then heat will transfer to this system. Then what will happen is that air which is inside our system, right? System will do the work on the surrounding. Therefore, the volume of this balloon is that the system is increased, right? This is what happened. right? By considering that energy transfer we are explaining here, right? So that it call it as first law of thermodynamics, right? So same as, just tell me.
Here in this video, sir, the work done on the system, is that correct, sir?
Sorry, I couldn't hear.
The work done on the system, yeah.
Yeah, no. Work done by the system. Our system is there in the. You're asking from that video.
Yeah, the video.
Yeah, in the video that the volume expand. No?
Yeah.
The volume expand mean that system doing work on the surrounding.
Okay.
Right. Right. That is our W. Then if system doing work, that means that is plus. If you do the work on the system, that means if you do the work, what will happen? The volume will be decreased. We have to compress. Somewhere we have to apply the energy and force from outside.
Okay.
But there, energy and force will be happen from the inside. Therefore, that is expand. Right? So here also I have the YouTube. They have videos prepared already. So I will just playing. See. Watch everyone, and while playing, I will explain, right? Right. This is the first thermodynamics. Energy conserved. It can be neither created or nor destroyed. And so, that means energy is conserved, like constant, right? We can create or destroy. Only we can change one form to another form, like thermal into chemical energy or mechanical energy, like that. Our equation, but here they have written as plus. Don't need to confuse, right? Then if it is plus, the W is here, work done on the system, right? Not done by the system, right? That here they have put plus mean that work is when system doing work, they will put minus here. Then automatically the minus will be come here, right? They are repeatedly doing some works, right? Here, they are going to explain what is system, what is happening, right? Right. The temperature difference, you know that the hot part, then according to because of the temperature difference, the heat transfer to the system. Right. Because when the balloons expand, because the hot water we added give some heat to the system, therefore that the system try to do work. Therefore, it will expand. Here, they are explaining before what they have done, right? So according to their equation, they have saying W is minus, but in our equation, work done by the system in plus, right? What they are doing is here they have to make a system, right? They have to give in the first experiment they have gives heat, okay? They have given energy to the system, right? Here they have to make the heat transfer from the system to surrounding. Then see what will happen. Therefore, they are heating. There's no any water or any something in the tin, right? Just air and the tin there. So when we heat up the tin, what will happen? In the which air, that air which is inside the tin will be heat up, right? That air will be heat up to 100 or more than 100 degrees Celsius, right? Then when we put it in the cold water, what will happen? That heat which have in the system will transfer to the surrounding. Right? That's just what I have done, right? So that heat is, that means that heat transfer to the cold water. Therefore, there should be a work done on the system. Right? Then surroundings should have to do work on the system, so it will push and make it crash, right? Right? I think you should understand what is happening there is, right? System is air and the aluminum tin, right? That is a system, right? So first they are heating up. That means that they are increase internal energy of the that air, right? So that what will happen is when we introduce cold water, that heat will automatically flow to the surrounding because of the temperature difference. That time Q is minus. We know Q is what? Heat added to the system. But now heat is extract, right? Heat is flow from the system to surrounding. Therefore, heat, Q is minus. And there's no time to any changes of the internal energy, right? If you want to change the internal energy of the ARO system, we have to give some time, right? There's no time, right? In millisecond, that is happening. Therefore, delta Q is 0, right? So Q is minus. Therefore, W also in our equation, W should be minus, right? In here, minus, W is minus. Sorry, Q is minus. Therefore, they have in their equation, they have get plus. That means work done on the system. In our equation, both are minus. Then it will be W also minus. That means heat done on the system. Then surrounding should do on the system. Surrounding should have to work on the system. Therefore, there will be a decrease of volume in the system, right? Therefore, in the middle part, it is flexible, no? Therefore, that part will be compressed and become it crash, right? It is follow from this system to surrounding. Therefore, work done on the system. Right? You can see, right? The surrounding will be do the work on the system. That means there will be a compression, right? There will be a pressure, the volume decrease, right? Volume decrement in the system, right? Right. Right. That's it. So this is our this is our two experiments. I think you all understood, right? That the second video you can get from YouTube, right? There is a lot of videos that are experimenting that first law of thermodynamics, right? I get these two type of experiments because one is work done by the system, that is balloon and the water bottle. Then other one is work done on the system, that is that tin, right? Aluminum tin. So in both cases, the difference is there is no internal energy changes, and the difference is only that heat transfer directions, right? In first case, the heat will be transferred to the system. The second case, heat will be transferred from the system to surrounding. Accordingly, that work done on the system and work done by the system will be changing, right? So that is end of this experimental experiment session, and I have to give more one example. So which is in the lab sheet, right? I think you all. So the lab sheet, right? I'm going to explain about this heat engines, right? One of the application of this thermodynamics, first law of thermodynamics, right? So in your discussion part also they have asked, I have asked, right? So ask you to write the discussion, right? Analyze the working of IC engine, that means internal combustion engine, right? With the first law of thermodynamics. That means if there are any heat or if there anything in anything we have we are doing heat to do any work or something, there will be a first law of thermodynamics mostly, right? So same as IC engine also, we are producing heat inside the cylinder, right? Then using that heat, we will the system will do the work on the surrounding, right? That's how it is operated. Right? You have to analyze, right? Just I will discuss about this also in this description. You have to discussion. You have to write your own, but I have to take it as an example and discuss with you. So as this is very brief practical, so therefore, so the first part is we have done this two demonstration. So for demonstration, you have to write on the observation and those things, right? But you have seen on the video. So just by using the knowledge, and if you do it in your home, you can do it. And somehow you have to write it right on the observation and the observation of this through demonstration of according to this first law of thermodynamics, right? So these are the discussion part. Now we will move to the heat engine, right? So when we after explaining this one regarding this session, I will give you 20 minutes. So you can ask any doubts, right? If you don't understood, you can ask. I will explain again, right? Don't need to be afraid of anything. Just ask. It is we are conducting to accomplish our objective. That means you are able to understood the application of first law of thermodynamics and able to understand what is happening, the machines and devices where we use this law, right? So one of the example is very known example is heat engine, right? In a one is coming now. I don't know what that's happening. So I will ask randomly. After that, I will ask questions, right? After explaining this one, randomly I will ask questions. I don't know who came now. 44. Who is 44? Can you hear me? Who is ET 044? Do you hear me?
Yes, sir.
044. You came now, no? Why you are late?
No, I'm not late.
No, I think 044. Someone joined and.
Sir, I am 064.
Yeah,
No, sir, disconnected.
Yeah. You came now, no? Why you are late? Do you hear me?
Hello, sir.
Yeah. What is your name?
Sir, disconnect.
Disconnected. So you understood?
No, sir.
Have you been for this session?
Dilshan, sir. Yes, sir.
Okay. Your network is very low, I think. Right. So just mute your mic. Doesn't matter, right? After explaining these things, I will ask one by one. Randomly, I will ask some questions for some of you. So later you can discuss, right? Anything regarding this particular discussion, questions, or anything, right? So okay, tell some others, right? I think 25 are here. I think 6 of you are not here. I think according to the Niranjan's calculation, I think 31 people or something. Then 6 of you absence. I will note it down, right? Then I will give the attendance for 25 people, and I don't know about other 6, right? Just inform them, right? At least they can join to other practicals, right? So this the heat engine, combustion engine is widely we are using for our industrial purpose in the companies and for our day-to-day life, we are using this internal combustion engines, right? In at vehicles or many devices or anything, there will be a heat engines, right? Most of the applications, right? So if you look at that, where it is that thermodynamics, first law of thermodynamics, right? Just we can take just look at that right side picture, right? There's two pictures. In the right side pictures, you can see that the circle is the system, right? That is heat engine, right? The system is in reality that will be the air, right? That space, the piston and the cylinder, space between the piston and the cylinder. That will be the system of that heat engine, right? You can see there is a Q in. That means heat is transferred from surrounding to system. That means, and also there is a Q out, right? But you can see if we consider the Q out is neglected, right? So there should be that heat come out from this. If you take a combustion engine, you can feel heat, right? If you're near that engine, right, working engine, you will feel some heat, right? That will be this Q out, right? That is a loss, right? So there's no machines, right? Just in no machine we can convert 100% heat energy to work, right? So there will be a loss anyway. So that will be the Q out. They have written as Q out, right? But in here, to check the thermodynamics, first law of thermodynamics, you can see when we are adding Q, how we are adding mean, if you take the combustion IC engine, heat engine, right? We have to supply the fuel air mixer, right? Fuel and the air mixer. Right? From the carburetor, we will supply the fuel air. That contain the what fuel will contain the fuel will contain the chemical energy, right? It will come into the system. That means that piston, right? Piston and the cylinder, right? Part. Then using spark plug, we will introduce the fire. Then it will burn, right? It will burn. In that time, how we will transfer the heat from the outside to inside, right? From that outside surrounding to system. Then when it burns, what will happen? That all chemical energy from that fuel, right? Transfer to change into heat energy, right? Then if we change it to heat energy, what will happen? Then automatically the system will do the work, right? That is W, right? That is W. That's how the piston move, right? In this left side picture, you can see in the first picture, the picture A, right? In the picture A, you can see when we add to the heat, that means when the combustion starts, what will happen? That heat energy will be converted into, right? If we supply some heat to the that balloon and the bottle, what has happened? That system, that the air which is inside the balloon and the bottle, start to do the work on the surrounding. That's how this piston move this way, according to the picture A, right? Then from that movement, we will get rotational motion, and we will convert it heat energy into mechanical, that work into mechanical rotation, right? That's how we are doing in this heat engines, right? I think you all studied in the lectures or something. I don't know if you have explained about this type of example or not. I don't know. So I just took this one. So this is how this heat engines work, right? So someone is coming, I think, okay, 26. Leaving, and I think they have, someone have network problem, okay. So in the picture A, they have mentioned that when we add the heat, that will the system will do on the do the work on the surrounding, right? Then later, yeah, the B part is describing the work, right? If you want to find out the work, that work is that the pressure into volume change. Then that should be the work, right? The volume change according to by calculating the movement of the piston, you can calculate the volume and the volume change and the pressure, right? That will be the work done by the system, right? So then the third picture C shows the return, right? Return movement of the piston. When it return to the initial position, what will happen? That burned air will be right push out to the surrounding, right? For that movement, that it will surrounding that piston will compress the air. That means it will do the work on the system, right? Because volume is decreasing, right? But it is very low, right? According to this respect to this work, right? Which is done by the system, right? Because when it system is doing work, there is a high pressure and high temperature, and when it's burned, air fuel mixer, there will be high pressure and high temperature, so that the work will be very bigger one, right? So when it returns, there will be there's I think that temperature and pressure is very low, right? So that it will just push and remove the combusted air, right? Then later, again, we have to introduce the air fuel mixer to that cylinder, and again start the plug and start the burning, and again it will that system will do the work on the surrounding, like that. This it will come like a circle, right? It will in the three this you know that you have already studied the combustion engine, right? Heat engine. It will then it will move like circle, right? So again we will doing this first law by using this first law of thermodynamics. We will convert the heat energy into work, right? So this heat engine is a one device, right? We have used this heat energy. We have used apply the first law of thermodynamics to convert the heat energy into work, right? If you take any example where we convert the heat energy into any work or any mechanical energy form, there will be a first law of thermodynamics, right? So that's it. So this is the end of the session, I think. So I will just ask some of you that do you understood or not? I don't know. Okay, tell me, Tusant, 098. Tusant, are you here? Tusant, 098. ET 098. Tusant. What has happened to them? Okay, tell me Aluthuvatta, DRD 02.
Yes, sir.
You are so
Is that okay, sir?
yeah, it's okay. To me, it's fine. I think
Sorry?
you are traveling somewhere.
No, sir. I'm in home.
Okay, it's very noisy now. So, Elizabeth, tell me where we tell me some application where we applying this thermodynamics.
Sure.
Can you tell me some application?
In combustion engine.
No. It is better to keep it mute your mic. So I don't know what you're doing. So let's move to the Midhusan. Midhusan 059. Midhusan, are you there? Midhusan? Or any volunteer? You can tell me your index number and I'll ask questions. Or if you have any doubt, you can ask, right? Is there any volunteers? Or do you all understood? I don't know. Some of you are answering. Others I don't know what I do. Sugandha Bala. Sugandha Bala, are you there? 092. Please, can you talk to me? Please unmute your mic and talk to me. Sugandha Bala. Sugandha Bala, do you hear me? What are you doing? Or I don't know what you are doing. Then tell me who is batch rep for your batch.
Yes, sir. I am the batch.
Yeah, what is your name and index number?
MKP Madhushan 2018 ET 053.
053, okay. So, what happened to other people? The 6 of your batch?
I don't know, sir. I think everyone is there.
Yeah, in the group, right? Do you have info now?
Yes, sir. Yes, sir.
Yeah,
Already.
okay. Then tell them they should participate in other next practicals. Otherwise, they'll be in trouble. Okay. So
Sir, someone have to coverage problem and signal problem.
yeah, okay. Then he should talk to module coordinator, right? Ask him to talk to Niranjan sir, right? So,
Okay.
so
I already informed Niranjan sir.
okay, then it's fine. Okay, then it's okay, no problem. So, can you understood this application of this law, first law of thermodynamics? Can you understood?
Yes, sir.
Yeah. Then
Yes, sir.
can you describe to me how what is happening for this this system, the balloon and the bottle, when we give some heat, what will happen? What is happening inside? Madhusan? Madhusan?
Yes, sir.
Yeah. Do you have any problem?
No, sir, no.
No, tell me, then explain me. What really is happening? I explain now. I show you some videos and video clips, right? I think you all understood. Very simple thing, simple experiment, right? This one. So just I'm asking, what is in here we are applying from this by using hot water, we will apply the heat from the to the system. Then what is happening?
I can understand, sir, but I can't explain it. Language problem, sir.
Okay. It doesn't matter. Okay, no problem. Right. Then the energy which we gave to the system that will transfer as work, right? Exactly that will be converted as work which have done by the system, right? That is happening exactly in the IC engine also, heat engines, right? So it's very simple thing. I think. Do you have any clarification or anything? Please, you can ask anything, right? Or if you shy to ask or anything, you just type in your chat box, right? Type in. And please just everyone tap your index number to the chat box. Put it your index number, only just index number, right? I just have to take as attendant. One, two, three, four, five, six, 7, 8, 9. Only 22. Okay, someone asked some questions. What are the machines used in this practice? Right, any machines, right? If we take which machines, right? Where we burn something, where we use heat, right? As a right, as one process, right? if you take a power plant or something, right? In coal power plant or anything, right? There we will burn the coal, right? So then from that heat energy, we will do some work, rotate dynamo or something, then we will produce electricity. If you take jet engine, right? There is also, and any type of engine, or if you take rocket engines and steam engines, right? If you take the steam engines, what is happening? We have to make steam, right? How we will make steam? We have to burn something, and we have to produce the steam using water, right? From the water, right? So for that we have to heat up, right? Then we will heat up and convert it as steam, and then we will, using that steam, we will rotate the engine and we will produce electricity, anything, right? So in every vehicles, right, we have engines and combustion IC engines, right, in many vehicles and many transportation equipments, devices. And if you look at our house, and most of the things working under this use electricity, right? Therefore, directly we are not going to use heat, right? But if you look at behind that electricity, what is happening? We'll use heat to produce electricity, right? Then we will simply use electricity to do electricity to operate several machines and devices, right? That is happening. So mainly that the big form of energy came from heat, right? If you take that sun, right? You know, I think you all know that the 70% of energy we have came from sun, right? If you take that one plant, right, that the one when is the plant growing, right, we should it should be able to catch the sunlight, right? Otherwise it won't grow. That means it will get the energy from the sunlight, right? Then it will grow, and by eating that we will get energy, right? That means that there will be heat energy will be converted as chemical energy and stored in the plants and everything. Then we will eat, and that chemical energy we will get from that foods, right? So everything is under the sun. You can see it is a lot of energy in heat forms, right? So in directly in the solar panels also, just directly from the heat will produce the electricity. Right? So everywhere we are using electricity, sorry, heat. But okay, it's the gas balloon example for first law thermodynamics. Yes, the gas balloon. That is also first law of thermodynamics, right? The both experiments are explaining the first law of thermodynamics, right? That is the concept, right? Siam, right? Siam asked, right? Therefore, we have two experiments. That first law of thermodynamics means that equation delta Q is equal to Q plus Q minus W, right? Then mostly the Q mean the heat or the energy transfer, right? If the energy is transferred from the surrounding to system, that will be plus. If the energy is transferred from the from the system to surrounding, that will be minus. The direction, when the direction of energy transfer change, that sign also change, right? That the impact also change. That is happening in both. That's the difference between the both experiment, right? You all understood, I think. So in one section, the energy is transferred to the system. In other experiment, the energy is transfer from the system to surrounding. That is happening, right? So, okay, these are the questions. So how many are here? 92. So only I think 1, 2, 3, 4, 5, 6, 7, 8, 22. 1, 2, 3, 4, 5, 6. Only 22 have put this index number. Why? What happened to others? How many are here? Yeah, 23 people are here. I think one of you didn't put your index number. Please put your index number to the chat box so that I can note it out and I can take it as attendance. Okay. So anybody have any questions? Right? Okay, 28. Okay. So altogether 23 people have participated. Okay. So this is so this is the end of this session, right? I think you all understood at least what is yeah, someone asked do you share the video, right? Yeah. I think we don't need to watch it again, but that those who are absent, it is better to watch it at least. So they will automatically share these things and YouTube or something, I think. So it is already recording, right? It is already systemized in the Zoom. So they'll share it. So share it to the LMS, right? They will, I think, if I can access this video, then I will share it to the LMS, right? And there's a notice and information. The Niranjan already explained. I think you have 1 week and 1 week for this lab report submission and 1 more week for the deadline, right? That means if your deadline is 1 week, but if you can access that link up to 2 weeks, but it's better to submit within 1 week so that you will get full marks. And I will, if you can access this video, I will upload it in the same link, right? In the practical sessions, in the LMS link, you can access. And from that, follow that link. I will using practical tool, practical 3 like that. I will using those create this that link and folder, and I will upload that lab reports, right? Before at least 5 or 6 days. Please go through the lab sheets before attend this practical session, please, so that at least then you will you can get more out of this session, I think. Someone is coming now. I don't know. So please, I think if anyone did not type your index number, please type it in the chat box so that I can take it as attendant for this practical. I think 24 people are here. I think one of you haven't write that index number. So if anyone have any problem regarding this session, you can ask now, or if you want, you can ask. You can contact me regarding that writing lab report, right? So just for this lab report, you have to write the index discussion part, right? And you have to write on the theory, right? There's no calculation and graph or anything, calculation or any observation. So in the discussion part, they have asked to write the observation, right? From this out of this two demonstration, right? One is the balloon and the bottle, another one is right aluminum tin, right? So you had both. So both of that you have to write on the observation and explain it, right, clearly. And then before that you have to write on the theory, right? You have to write on the theory what is the equation, what is that each part of the equation representing, and those things you have to describe. And what is first law of thermodynamics. And if you want, you can write it write the applications, right? I didn't ask in the discussion because the second question is according to the one application, right? IC engine, combustion engine, right? For that application, I gave you some introduction, like I just introduced how it's work, that combustion engine, so that you can get and refer from internet and YouTube videos. Then write your own, right? Describe how it's work, right? So when you are describing, please, if you can write some sketch or something, just do it, right? And if you can write it in the points form, it's better to write it as points form, right? So, and theory and the discussion, that is for this practical one, right? So this is experiment 1. So, and when you're submitting, please only you can submit as PDF form, right? Only you can submit the file as PDF form, right? Just write your own, right? Write your own by using, right, your own handwrite.
Sir,
Yeah.
we can type, sir, by using MS Word, and we can change that to PDF.
Yeah, you can share it to your colleagues also. That's why I ask you to. That's why we are asking to follow this old method, writing by hand, right? So at least why we are asking these things is, at least after this, after some time, that means let's say after 1 year or something, you will at least remember these things. When you are writing, at least you will get to know something, right? Some of you are, if there are any possibility of copying or something, then most of you are trying to do that thing, right? It is not good for the future. So that we will ask you to do that like this, right? So that I will ask you to write in your hand, right? And take a photo, and you have that experience. I think take a photo and make it as PDF. I think in the mobile phone we have that apps, I think, called PDF Maker or something. Scan and automatically make it as PDF. I think use that one and scan it and make it as PDF file and just upload it to the LMS. Okay. So from that LMS, I will collect and correct it. Okay. So you have 1 week deadline. So when you are attending next practical next Monday, you should prepare and you should at least go through that lab scene, right, before attend this practical session. So do you all understood what I am saying?
Yes, sir.
Okay. So 28, I think. Okay, 28. Okay, I think everyone is okay. So we will stop with this session right here. So if we can access this video, it is recording automatically. If we can access This video I will upload it to LMS. You can refer and write it your lab report and submit before the next Monday, right? Before 1 week, right? That will most probably you will get high marks, right? If you submit before due date. So thank you very, very much to everyone to participate in this practical session, and please ask to others, please at least participate from the next practical onwards, so that they won't lose any marks for this practical sessions, right? So thank you so much. Bye bye. See you in next practical.
Thank you.
Bye.
Thank you, sir. Thank you, sir. Yes, sir.